Good morning, students. So, last couple of days, we discussed about the DC generators and DC motors. So, different concepts we have to discuss it in DC generator as well as DC motors. So, in DC generator, constructional and operational of DC generators, and also characteristics of DC generators, the EMF equation, derivation of EMF equation of a DC generator, how to build up a voltage in a DC generator, separate like a DC generator, what is meant by critical field resistance and what is meant by critical speed, right? So we all discussed it in the first unit, that is DC generator unit. Coming to the DC motor, operational construction is same as DC generator. DC motor and DC generator construction is same. Operation point of the operation of DC generator, then back EMF, significance of back EMF, maximum power equation. After then, so torque equation, speed control of DC motors, characteristics of DC motors, applications of DC motors, spin bond test, and 3-point start. These are all discussed in the second unit, and then doing problems on torque, speed control, and also characteristic, efficiency losses. Efficiency losses also discussed in the theory as well as problems. Different types of losses occurred in the DC motor as well as efficiency. Condition, derive the condition for maximum efficiency. Copper loss is equal to iron loss, right? So all these things will be discussed in the last month. Right now, we go through the unit number 3, that is transformers. Last 2 units comes under DC. So DC generators, DC motors. Now coming to the transformer, nothing but AC. Those 2 machines are rotating machines, but transformer is a static device. So it does not rotate any part in the transformer. Any part in the transformer does not rotate. That's why transformer is also called as a static device. Static means so sitting on one place. It is not moving. That is nothing but static device. The EMF induced in the static device is statistical induced EMF, whereas in EMF induced in the rotating machines is dynamically induced EMF, right? That means, so the magnetic field is stationary, conductor is moving. At any time the conductor cut the magnetic field, automatically EMF is induced, that is the dynamically induced EMF. Here in reverse case, right? Transformer. So these are the contents of third unit. In third unit, two divisions are there. First division transformers, second division 3-phase circuits. So syllabus penchadu la mee seniors kante seniors only transformer maatrame ledu. Meeku extra ga 3-phase circuits ani NA lo oka chinna part iskochu kabatti. So introduction, principle of working, construction details, EMF equation, phasor diagram on no load condition and load conditions, then equivalent circuit, then losses and efficiency. So losses and efficiency topic we cannot study it here, but just we can know the what is the difference between the losses in DC motor, losses in transformer. That's enough. Why? Because same losses are repeated, but only one loss is not coming, that is a rotational loss or mechanical losses or frictional and windage losses are not coming. Why? Because it is a static device. So rotating aitene frictional and windage losses vastayi, rotating kaakapothe avi raavu. Ingem remaining unna losses, copper losses, iron losses. Aa rendu losses ఈ ట్రాన్స్ఫార్మర్లో ఉంటాయి. అది మీరు కొత్తగా చెప్పాల్సిన ఉంది. కాపర్ లాస్ ఎక్కడ అక్కడ అవుతాయి? వైండింగ్లో. ఐరన్ లాసెస్ అనేవి కోర్లు. ఐరన్ లాసులు మళ్ళీ హిస్టరీస్ అండ్ ఎడ్డీ కరెంట్ లాసెస్. అవి ఎందుకు అక్కడ అవుతాయి, ఎలా రెడ్యూస్ చేస్తాం, అవన్నీ అక్కడ ఆల్రెడీ చదువుకున్నాం. సేమ్. సో ఎక్స్ప్లెయిన్ ది in one exam in one JNTU examination paper. I will send you later all papers of ET. They are asking second unit, explain different losses occur in DC motor. Coming to third unit, explain different losses occur in transformer. Same question, but so you can mention here DC motor, here mention transformer. One losses is escaping, that is nothing but rotational losses. We can explain copper loss, we can explain iron loss, that is hysteresis and eddy current. We can explain rotational losses in DC motor, but here copper and iron only. Copper losses and iron losses is nothing but eddy current and hysteresis losses. And efficiency is same. Whatever conditioner efficiency is also same. Copper loss is equal to iron losses, right? So that's why this topic is already all members also known topic, but important. Next, regulation, OC and SC test, very important. In your laboratory also these tests will be available. So in DC generators, which test is available in laboratory? Magnetization characteristics of a DC shunt motor. Magnetization characteristics are no load characteristics, or OCC, open circuit characteristics, that is available in laboratory. Coming to the second unit, Swinburne test, brake test, both are comes under in our laboratory. Now coming to third unit, this test, OC and SC test, open circuit and short circuit test of a transformer. So this is also very important. First, suppose you have to pick one question from third unit is nothing but first you have to pick this question. Explain OC and SC test, or explain how the copper losses and iron losses are determined with the help of test conducted by the single phase transformer. Simple OC and SC test, right? So very important. In second unit, first question is speed control of DC motor. Explain speed control of DC motor. Otherwise, explain characteristics of DC motors, right? Similar manner. So here third unit, explain OC and SC test, right? So these are the transformer part, syllabus of transformer. So first go for the introduction. Generally, what is meant by transformer? A transformer is a static device. A transformer is a static device which transfers energy from one circuit to another circuit without change in frequency, with change in voltage and current. Transformer is a static device which transfers the energy from one circuit to another circuit without change in frequency, but with change in voltage and current. So the main, we can consider this is a transformer, and it is a primary winding and it is a secondary winding, right? Primary winding and secondary winding, right? Primary, so this is one winding and this is another winding. Primary winding is nothing but a winding is connected to the supply system. A winding is connected to the supply system. That winding is called primary winding. A winding is connected to the load circuit. A winding is connected to the load circuit. That winding is called secondary winding. Look at the figure. So the winding is connected to directly power station. That is nothing but supply system. Is known as primary winding. So this low voltage may be stepped up to high voltage. That's why this is step up transformer. The transformer located at the powerhouse is step up transformer. The transformer located at nearby our houses is step down transformer. Why? Because so the generating station is far away from our houses. Suppose look at the Srisailam right bank powerhouse. So in Srisalem, two powerhouses will available. So right powerhouse and left powerhouse. So that means in between these two powerhouses, so river will be flowing. Krishna river will be flowing. Other side is Telangana. Now right side is Kurnool district. So left side is Mahbubnagar district. So right side is Krishna, Kurnool district. That's why the right powerhouse is belongs to the AP government, and the left powerhouse is belong to the Telangana government. Left powerhouse is underground, excellent construction, and they will generate power in a rainy season. Why? Because water is available in a dam, in plenty of water is available in a dam. That's why they utilized as much as possible to generate the power. And second one, right canal. This is belongs to Andhra Pradesh government. So this is a digital system. Why? Because in 1990, so I think around 1998 or 2000, um, 2018, a heavy flood is destroyed the right canal, right canal alternators, turbines, all the auxiliary equipment installed in the power station. That's why, so you can equip it with a digital one with the help of Japan country. That's why right powerhouse is a digitalized powerhouse, whereas left powerhouse is a analog type of powerhouse. Right? So that means, so generally what is transformer is nothing but transformer is a static device which transfers the energy from one circuit to another circuit without change in frequency, with change voltage and current. గమనించండి క్లియర్గా. మోటార్ జనరేటర్ ఏం చేస్తాయి? జనరేటర్ ఇస్ ఏ డివైస్, ఎలక్ట్రోమెకానికల్ కన్వర్షన్ డివైస్ విచ్ కన్వర్ట్ ఎనర్జీ ఫ్రమ్ సో ఎలక్ట్రికల్ ఎనర్జీ టు మెకానికల్. రైట్? ఏంటది? మోటార్. జనరేటర్ అయితే మెకానికల్ టు ఎలక్ట్రికల్ కన్వర్ట్ చేస్తుంది అక్కడ ఎనర్జీని, బట్ ఇక్కడ ఎనర్జీని కన్వర్ట్ చేయటం లేదు, ఎనర్జీని ట్రాన్స్ఫర్ చేస్తుంది ఒక సర్క్యూట్ నుంచి ఇంకో సర్క్యూట్ వితౌట్ ఎనీ ఎలక్ట్రికల్ కనెక్షన్. So with the help of mutual induction principle, the transformer is working based on mutual induction principle. Right? So what is mutual induced EMF, what is self-induced EMF, and what is the dot polarity, that all is studied in the NA third unit, I mean fourth unit. Right? Suppose same polarity, so positive voltage, positive sign, different sign, I mean different polarities, so we get the negative sign like that. So transformer is working based on the principle of mutual induction between two circuits. The two circuits are not electrically connected, the two circuits are magnetically connected. So right? So look at the transformer nearby your house, right, clearly. So that is a 11 kV by 230 volts or 11 kV by 440 volts. The transformer rating is 11 kV by 230 volts. That connection is directly given to the all houses. 11 kV by 440 volts is given to the small catalog industries, that is Kutira Parishramulu. Otherwise, three-phase agriculture purpose, three-phase motors, where three-phase supply is required, that at that industries may utilize it the 440 volts supply. Otherwise, single phase supply is nothing but, so our houses may require 230 volts, right? So that's why nearby our houses, transformer rating is 11 kV by 230 volts, step down transformer. Generally, types of transformers are different types of transformers are available, but mainly step down, step up, depending upon the voltage. Step up voltage means a lower voltage is transferred to higher voltage. Step down means higher voltage is step down to lower voltage, depending upon voltage, but depending upon current, reverse, right? So look at the slide. Transformer is a static device It works on the principle of mutual induction. So sometimes they are asking define transformer and give the principle of operation 2 marks. So 2 marks means we don't need explain all the operation. Just so transformer is a static device which transfer the power or energy from one circuit to another circuit without change in frequency. Enough. Suppose we want to write extra with change in voltage and current. ఫ్రీక్వెన్సీ చేంజ్ కాకూడదు, ఒక సర్క్యూట్ నుంచి ఇంకో సర్క్యూట్కి ఎనర్జీని లేదా పవర్ని ట్రాన్స్ఫర్ చేస్తున్నప్పుడు. బట్ ఏం చేంజ్ కావాలి, వోల్టేజ్ చేంజ్ కావాలి. లో వోల్టేజ్ నుంచి హై వోల్టేజ్ లేదా హై వోల్టేజ్ లో వోల్టేజ్. అదేవిధంగా కరెంట్, లో కరెంట్ నుంచి హై కరెంట్ లో కరెంట్. దట్ మీన్స్ ఏ ట్రాన్స్ఫార్మర్ ఈజ్ ఏ స్టాటిక్ డివైస్ విచ్ ట్రాన్స్ఫర్ ది ఎనర్జీ ఫ్రమ్ వన్ సర్క్యూట్ టు అనదర్ సర్క్యూట్ వితౌట్ చేంజ్ ఇన్ ఫ్రీక్వెన్సీ బట్ విత్ చేంజ్ ఇన్ వోల్టేజ్ ఆర్ కరెంట్. రైట్. సో దట్ ఈస్ ద of transformer and principle is mutual induction principle. So look at the figure, transformer construction, right? Look at the figure. So this is a winding is connected to the primary side of a transformer is called primary winding or primary coil, and a winding is connected to the secondary side is called secondary winding or a secondary coil. And this is the transformer core made up of silicon steel lamination. Transformer core, and this indication is flux. The production of flux in the primary winding is transferred to the secondary winding, is linking with the secondary winding that may help to EMF is induced, right? So the symbol of transformer is like this. These are the number of turns. Magnetic core, primary winding, secondary winding, right? Symbol of transformer. And then sometimes single line diagram. Suppose we have to draw the single line diagram. So the transformer will be right like this, like this. Primary voltage, secondary voltage. Now the principle of working of single phase transformer. Otherwise, working of explain the working of principle of operation of single phase transformer. Generally, the transformer is a static device which transfers the energy from one circuit to another circuit without change in frequency, with change in voltage and current, right? And it is working based on mutual induction principle, right? What is mutual induction? What is mutual induction means? So two separate coils are there. When two coils are inductively coupled, and if current in one coil is changed uniformly, then EMF gets induced in other coil. So EMF, that means suppose two coils are there, means suppose in one coil we have to given the supply, then the flux will be produced in the first coil that may be linking with the secondary coil. That means here also in secondary coil also EMF is induced. So right. So simple example, suppose the iron will be there, iron rod will be there, and magnet will be moving. So because of magnetic flux produced in the magnet, that may be the force may be affect on the iron. The iron piece will be attracted, right? So that means here the second part, that is iron, does not having any flux, right? The first coil only having flux, that is the magnet. For magnet we are giving the supply. Because of that supply, flux is produced. That flux is uniformly distributed. So that uniformly distributed flux, because of uniformly distributed flux, right? So that may be effect on the iron. Here also flux produced and EMF is induced. So same. That means two separately circuits, two electrical circuits or two inductively coils are placed in one place. Whenever we are giving the supply to the first coil, if current in one coil that is changed uniformly, so that means flux is produced. That flux is linking with the secondary coil through the mutual induction principle. Then because of that flux, an EMF is induced. An EMF is induced. in the second coil itself, right? So that is the principle, that is the definition of mutual induction. So mainly what is the principle of operation of transformer is nothing but simply we can say that in simple language mutual induction principles are, otherwise can clearly given Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction. Look at the figure. Operation. So primary winding, secondary winding, primary winding, secondary winding, and this is the core, right? Iron core, and this is the load circuit. Suppose whenever we are giving the AC supply to the primary winding, AC supply to the primary winding here, whenever we are connecting AC supply to the primary winding, so and primary current is flowing through the primary winding, that means IP is flowing through the primary winding. So whenever this IP will touches the number of primary turns that may produced in the primary flux in the primary winding. Why the flux is produced in the when ఎప్పుడైతే కరెంట్ అనేది మన సప్లై ఇచ్చామో ప్రైమరీ వైండింగ్కి, ఆ ప్రైమరీ వైండింగ్ వల్ల ఆ సప్లై ఆల్టర్నేటింగ్ కరెంట్ వల్ల ఆ ప్రైమరీ కరెంట్ అనేది ప్రైమరీ వైండింగ్లో ఫ్లో అవుతుంది. ఫ్లో అయినప్పుడు ఎందుకు ఫ్లక్స్ ప్రొడ్యూస్ అవుతుంది? వాట్ ఈస్ ద మ్యూచువల్ ఎంఎంఎఫ్? Magnetomotive force, right? So the magnetomotive force is nothing but product of number of turns and current. IP and NP is nothing but number of turn, I mean MMF. Because of that MMF, magnetomotive force, flux is produced in the primary winding. That flux is linking with the secondary winding through the core. That flux is linking with the secondary winding through the mutual induction principle. Whenever the flux is linking with the secondary winding, because of that flux an EMF is induced in the winding, secondary winding. Because of that induced EMF in the secondary winding, an induced current, an induced secondary current IS is flowing through the load circuit. So this is about principle of operation of transformer. అంటే ఫస్ట్ మనం ఆల్టర్నేటింగ్ సప్లై అనేది దాన్ని ఆల్టర్నేటివ్ సప్లైని మనం ప్రైమరీ వైండింగ్ ఇచ్చినప్పుడు ప్రైమరీ కరెంట్ అనేది ప్రైమరీ వైండింగ్లో ఫ్లో అయితే ఆ ప్రైమరీ కరెంట్ ఎప్పుడైతే నెంబర్ ఆఫ్ టర్న్స్ టచ్ చేస్తుందో ఎంఎంఎఫ్ ప్రొడ్యూస్ అవుతుంది. బికాస్ ఆఫ్ దట్ ఎంఎంఎఫ్ ఫ్లక్స్ ఈజ్ ప్రొడ్యూస్డ్. దట్ ఫ్లక్స్ ఈజ్ ఆల్టర్నేటివ్ బికాస్ ఆఫ్ సప్లై ఈజ్ ఆల్టర్నేటివ్. సప్లై అనేది డీసీఓలో మనం ఆల్టర్నేటింగ్ సప్లై ఇచ్చాము, ఏసీ సప్లై ఇచ్చాము. Because of that alternating current, flux is also alternating. Whenever flux is alternating, zero maximum zero, negative maximum zero, like that. So at one stage the flux is mutually induced from the primary winding to secondary winding. Because of that secondary induced flux in the secondary linking flux in the secondary winding, EMF is induced. Because of that EMF, secondary current is produced. Because of that secondary current is flowing to the load circuit. అర్థమైందమ్మా? మనం ప్రైమరీ వైండింగ్ సప్లై ఇస్తున్నాం, సెకండరీ వైండింగ్ కాదు, సెకండరీ వైండింగ్ తీసుకుంటున్నాం. మరి సెకండరీ వైండింగ్ ఎలా వస్తుంది? ఎటువంటి ఎలక్ట్రిక్ కనెక్షన్ లేదు కదా మధ్యలో. ఈ వైండింగ్కి ఈ వైండింగ్ మధ్యలో ఎటువంటి ఎలక్ట్రిక్ కనెక్షన్ లేదు, ఓన్లీ మ్యాగ్నెటిక్ కనెక్షన్ మాత్రమే ఉంది. సో ఎప్పుడైతే సప్లై ఆల్టర్నేటింగ్ కరెంట్ ఇచ్చామో, ఆల్టర్నేటింగ్ వోల్టేజ్ ఎప్పుడైతే మనం అప్లై చేసామో, ఆల్టర్నేటింగ్ కరెంట్ అనేది ప్రైమరీ వైండింగ్ రావడం వల్ల అక్కడ ఆల్టర్నేటింగ్ ఫ్లక్స్ ప్రొడ్యూస్ అయ్యి, ఆ ఆల్టర్నేటింగ్ ఫ్లక్స్ అనేది ఇట్ విల్ లింకింగ్ విత్ ద సెకండరీ వైండింగ్ may produce the secondary induced EMF E2. Because of secondary induced EMF E2 and secondary current IS is flowing through the load circuit. So here just you remember two EMFs is produced, primary EMF, secondary EMF, primary EMF, secondary EMF, right? So we have to derive the EMF equation for primary winding as well as secondary winding. But whereas in generator, only one EMF, that is a rotating machine. E is equal to pi z n by 60 into P by A. But here, E1 is equal to some equation, E2 equal to some equation. So two EMFs, primary winding EMF as well as secondary winding EMF. Here, primary winding turns NP or N1, secondary winding turns so NS or N2. Primary winding supply V1 or VP, secondary winding voltage Vs or V2, primary winding current IP or I1, secondary winding current IS or I2, whatever it may be. Just so you can recognize or you can remember your own way. The indications are 1, 2, otherwise PS like that, right? So this is the classification of transformer. Depending upon the phases, single phase, three phase, depending upon the winding, step up, step down, depending upon the construction, core type, cell type. So this is third one is the very important for our syllabus. So explain the construction, core type, cell type transformers. They are asking 5 marks. Otherwise, define the write the difference between core type and cell type transformers. 2 marks or 5 marks, whatever it may be. So next construction of a transformer. So look at the ones we have to imagine transformer. So primary winding is there, secondary winding is there, in between these two transformer core is there, right? That means what are the parts of transformer? Winding, that is the primary winding, secondary winding, then core, right? Next, some parts also there. So we have to look at your nearby the transformer. So what are the parts of transformer is nothing but conservator tank, breather, right? So oil, right? Book hole relay. So many parts will be there. So first we go for the basic construction. Parts of transformer is nothing but core and winding. Main. So first core. Mainly basic parts are core and winding. Remaining parts will also there. First of all, magnetic core. Core is nothing but either a rectangular type or square type. Core is looking at a made up of a square type or rectangular type. That means in size wise. So in core, the vertical portion is called limb and the horizontal portion is called yoke. Right? The core is laminated for eliminate the eddy current losses. So already I am giving you one line. The core is made up of silicon steel lamination. Silicon steel is nothing but reduce the hysteresis losses. Laminations reduce the eddy current losses. Total, the core is made up of silicon steel lamination such that may reduce the iron losses. So look at the figure. So this is the limb and this is the yoke, and look at this is a rectangular type, right? And so L type, here we have to join the cores, I mean laminations. This is the L type, this is one L and this is another L type laminations. Like that we have to design. This is L and I. So L, I, otherwise like this. Rundu I type lamination, you have to take. We have to join the laminations with the help of L type laminations or I type laminations or E type laminations, right? Now coming to the winding. Winding is nothing but primary winding and secondary winding. The coils are used onto the limbs, right? Yoke మీద కాదు, మీరు గమనిస్తే లింబ్స్ మీద మాత్రం మనం వైండింగ్ చూస్తాం. వర్టికల్ పోర్షన్ మీద మాత్రమే మనం వైండింగ్ని చుడుతున్నాం, కానీ లింబ్ మీద హారిజాంటల్ పోర్షన్ మీద మనం ఎప్పుడు కూడా. సో దట్స్ వై ది కాయిల్స్ ఆర్ wound ఆన్ ద లింబ్స్ అండ్ ఆర్ ఇన్సులేటెడ్ ఫ్రమ్ ఈచ్ అదర్, రైట్. ఇన్సులేట్ చేయడం వల్ల ఏంటంటే లీకేజ్ అనే సౌండ్ రాదు. మీరు ల్యాబ్లోకి వచ్చినప్పుడు గమనించవచ్చు. సిలికాన్ స్టీల్ లామినేషన్ చేస్తుంటారు, దాంతోపాటు సో ఇన్సులేషన్, ఇన్సులేషన్ ఇస్ నథింగ్ బట్ వార్నిష్. Now primary and secondary coils are primary and secondary windings. So primary winding is nothing but the winding is connected to the supply system. The is primary winding. The winding is connected to the second load circuit, that is called secondary winding. These two coils are placed on the normally on limbs but not yokes. So to reduce the మోర్ లీకేజ్ ఫ్లక్స్, అంటే ఎటువంటి ఇన్సులేషను ఎటువంటి లామినేషన్ లేకపోతే లీకేజ్ ఫ్లక్స్ ఎక్కువగా ఉంటుంది. ఆ విధంగా చేయడం వల్ల తగ్గిపోతుంది. సమ్టైమ్స్ we may use cylindrical coils like that. Cylindrical coils is nothing but core type. Core type transformer may use cylindrical type and it is a mechanically strong one. Sometimes sandwiched coils. So sandwiched coils are may commonly used in shell type. Cylindrical coils are used in core type. Sandwich coils are used in shell type transformers. Look at the figure. This is the sandwiched coil. That means so HV followed by the LV, HV followed by the LV, high voltage winding followed by the low voltage winding, high voltage winding followed by the low voltage winding, like that. LV windings are split into number of sections where HV winding lies between the two LV windings. Look at the figure. LV in between two LVs HV winding will be placed. So this type of coil is called sandwiched coil. So because of this type of construction, the leakage will be controlled. So core types of transformers mainly step down, step up, single phase, three phase, but based on construction, core type, cell type, very very important. So look at the figure. Core type transformer is nothing. What is the definition of core type transformer? The winding is surrounded by the core. Core is surrounded by the winding. Core అనేది winding చేత కప్పబడి ఉంది. Core is surrounded by the winding. Whereas in cell type, winding is surrounded by the core, right? Look at the figure. These are the L type laminations. చూడండి ఎన్నిటిని ఒక బస్తా ఒక శాండ్విచ్ లామినేట్ చేస్తుంది. ఒక మన సన్న మీ ఎంట్రీకి కూడా దూరనంత విధంగా లామినేట్ చేస్తుంది. ఎంట్రీకి ఉన్న దూరం ఉంటుంది సందుచ్చినా కానీ లీకేజ్ ఫ్లక్స్ అనేది లీకేజ్ అవుతుంది. లీకేజ్ అయితే బయటకు వచ్చేసరికి సౌండ్ అనే సౌండ్ వస్తూ ఉంటుంది. బికాస్ ఆఫ్ పవర్ లాస్. ఆ లీకేజ్ కరెంట్ వల్ల పవర్ లాస్ ఎక్కువ అవుతుంది. సో దీస్ ఆర్ ది ఎల్ టైప్ laminations are used for core type transformer. These are the E type and I type. E type and I type are used for shell type transformers. And look at the figures. There is only one magnetic path, right? So this is the only one magnetic path. But coming to this cell type, two magnetic paths. This is one magnetic path. This is another magnetic path. Two magnetic paths. That means two sections are there, right? So it is a series circuit, but it is a parallel circuit. The difference between core type and cell type. Look at the difference. Single magnetic circuit, only one magnetic circuit. Here double magnetic circuit. Core has two limbs. Look at the figure once again. The core has two limbs. This is vertical part of transformer is called limb. Only two limbs. Compare the shell type, one limb, two limb, third limb. So in core type transformer only two limbs are there, but in shell type transformer core has three limbs, right? And it is a cylindrical coil. Core type transformer may use cylindrical coils, whereas in cell type sandwiched coils used, and preferable for low voltages only. Core type transformer is nothing but low voltage low voltage transformers, whereas in cell type high voltage that is power transformer. So, and coils are removed easily, coils cannot be removed easily. Suppose is there any problem occurred in the construction, so L type coils removed easily, this L type coils removed easily, but here suppose this in the third section, middle section having some problem, so we don't remove middle section limb separately, we can remove total E type lamination. That is the major problem for elimination of limbs is very easy for maintenance in core type transformer. Elimination of limbs is very complex in cell type transformers. So very important, 2 marks and 5 marks also. Now go for the another important question. First important question is define transformer and explain the working principle of single phase transformer. And second question, core type cell, explain core type cell type transformers, otherwise difference between the core type cell type transformer. And third question is very important, derive the EMF equation of a transformer, right? So look at the figure, this is the primary winding, right? This is the secondary winding and the flux, right? Primary winding having N1 number of turns, secondary winding having N2 number of turns. So on primary voltage is V1, secondary voltage is V2, right? Primary induced EMF is E1, secondary induced EMF is E2. So we may the notations are as your wish, N1, N2, NS, NP, NS, whatever may be, IP, IS, otherwise I1, I2, whatever it may be, you can use. So look at the figure, this is the alternating supply, and this is the maximum flux wave, 0 degrees, 180 degrees, 360 degrees. So now I am taking only half cycle. Why? Because remaining half cycle also similar to that of this one. That's why I am taking only half cycle, 0 to pi. Again we can consider quarter cycle. Why? Because change in flux is nothing but 0. Flux is 0, at pi flux is 0. So that's why there is no change in flux, 0 and pi. That's why I am taking it at this position, pi by 2. That is nothing but quarter cycle. So here flux is 0, but here pi m. So here there is a change in flux is there, right? So total cycle, that is nothing but T is equal to 1 by F. One time period equal to 1 by F. For half time period, so this is 1 by 2T, that is nothing but T by 2, 1 by 2F. A quarter, T by 4 or 1 by 4F. So look at the figure, the complete cycle T equal to, time constant is T and frequency is 1 by F. For half cycle, T by 2, that is 1 by 2F. Or for quarter cycle, T by 4 or 1 by 4F, right? And flux is maximum flux, flux equation is pi is equal to pi m sin omega t. So because it is a alternating flux. So because we are giving a alternating supply, right? And let us consider as usual. We know that N1 is equal to primary number of turns, N2 equal to secondary number of turns. Pi m is equal to maximum flux in the core, that is equal to flux is equal to B into A, right? Flux density is nothing but flux follow the ratio of flux to area surrounded by it. So that is Bm is equal to pi m by A, otherwise pi m is equal to Bm into A, right? So pi m is equal to Bm into A Webers. F is equal to frequency, right? Now according to Faraday's laws of electromagnetic induction, what is the equation of EMF induced in a conductor? E proportional to d pi by dt, same as DC generator. E proportional to d pi by dt, where d pi is nothing but change in flux, dt is nothing but change in time. Akkada kuda enti change in flux is nothing but pi m minus 0, that is pi m. But akkada number of poles enni unnai, aa flux ni produce chese enti poles, enni poles unnai, p number of poles, that's why p pi akkada manam teeskunnadi by n by 1 by 60 by n, that is nothing but p pi n by 60 వచ్చింది అక్కడ. Here also similar. So according to Faraday's laws of electromagnetic induction. So average EMF per turn is equal to d pi by dt, where d pi is the change in flux, dt is the change in time. So d pi, that is nothing but change in flux. మనం తీసుకున్న quarter cycle, minimum flux 0, maximum flux pi m. What is the difference between these two? Pi m minus 0, that is pi m. Pi m by time required, as usual, same ditto. So మనం తీసుకున్నది ఏంటి క్వార్టర్ సైకిల్ కి టైం ఎంత t by 4, in terms of frequency 1 by 4f, right? So that is pi minus 0 by 1 by 4/5, that is 4 pi fm, 4 pi m, that is the average EMF per turn volts. This is the average voltage. Average voltage is nothing but DC value, not a AC value. But for our transformer, we require AC value. What is the difference? What is the relation between the AC value and DC value? Form factor. RMS value to average value. The ratio of RMS value to average value is nothing but form factor. For a sinusoidal value, the form factor is 1.11. So now form factor is equal to RMS value by average value, that is equal to 1.11. We have to find RMS value. We know the average value. We know the form factor. So 1.11 into average value. 1.11 into average value. Already you have to find the average value, that is 4f pi m into 1.11, that is 4.44 f pi m, right? And how many turns in the primary winding there? N1 number of turns. How many turns in the secondary winding? N2 number of turns. Therefore, so E1 is equal to 4.44 f pi m N1 volts, E2 equal to 4.44 f pi m N2 volts. This is the EMF equation of a transformer. These two equations, E1, E2 together called as EMF equation of a transformer. ఈ రెండింటిని కలిపి మనం EMF equation of transformer అంటే కానీ ఒకదాన్ని రాసి నేను EMF equation రాసిన అంటే కుదరదు. They are reducing 1 or 2 marks. Suppose you don't write E2, they are reducing 1 or 2 marks. That's why. So primary winding EMF 4.44 f pi m N1 volts, E2 equal to 4.44 f pi m N2 volts, right? This is the, suppose you have to abbreviate that one. We know the pi m is nothing but Bm into A, right? 4.44 f Bm into A into N1 volts, 4.44 f Bm into A into N2 volts, right? Suppose we have to abbreviate the flux. So suppose from the above equations, divide the equation 1 by equation, that is divide the E1 by E2. Divide the E1 by E2. 4.44 f pi m is cancelled to each other. N1 by N2. E1 by E2 is equal to N1 by N2. Otherwise, E1 by N1 is equal to E2 by N2. Constant value. E1 by N1 is equal to E2 by N2. That is EMF per turn is same for both primary and secondary windings. Suppose they asking calculate the EMF per turn for both windings. That is nothing but first you have to calculate E1 by N1, then you don't calculate the E2 by N2. Why? Because E1 by N1 is equal to E2 by N2. That's why the EMF per turn is equal for both windings. For ideal transformer, there is no leakage, there is no losses. E1 is equal to V1, E2 is equal to V2, right? That is the ideal transformers. And relation, so we can look at the E2 by E1 is equal to N2 by N1 is equal to V2 by V1, or I1 by I2 is equal to K. This is the transformation ratio K. Transformation ratio K. E2 by E1 is equal to N2 by N1 equal to V2 by V1, right? So very, very important. This is very useful for calculating the problems on EMF equation and also equivalent circuit. So this ratio is always following you up to third unit completed. That's why you have to remember transformer ratio is E2 by E1 is equal to N2 by N1 is equal to V2 by V1 is equal to K, right? So K is the transformation ratio. Suppose K greater than 1, then the type of transformer is called step-up transformer. Why? Because K greater than 1 is nothing but N2 is greater than N1. Number of అనుకోండి, step up voltage కూడా ఎక్కువ అవుతుంది. సో దట్స్ వై సెకండరీ నెంబర్ ఆఫ్ టర్న్స్ ఎక్కువగా ఉంటే ప్రైమరీ కంటే అది స్టెప్ అప్ ట్రాన్స్ఫార్మర్. సెకండరీ వైండింగ్ టర్న్స్ తక్కువగా ఉంటే అది స్టెప్ డౌన్ ట్రాన్స్ఫార్మర్. K greater than 1 step up transformer, K less than 1 step down transformer, K equal to 1 isolation transformer, right? For ideal transformer, so input volt ampere is equal to output volt ampere. That's why, so I1 by I2 is equal to I2 by I1 1 by K, I1 by I2 is equal to K. That's why, so here this equation is E2 by E1. You have to remember clearly, transformer ratio K is equal to E2 by E1, N2 by N1, V2 by V1. Otherwise I1 by I2. Current matram reverse avudante, right? Look at the problem. So a maximum flux density in the core of a 250 volts by 3000 volts 50H single phase transformer is 1.2 Weber per meter square. The EMF per turn is 8 volts. Determine the primary and secondary winding turns and area of the core, right? So E1 by, generally the given flux density in the core, that is Bm is equal to 1.2 Weber per meter square. EMF per turn, that is nothing but E1 by N1 equal to 8 volts, right? Determine the primary winding and secondary winding turns annar. So E1 by, so ఇక్కడ ఈక్వేషన్ కొంత తప్పు రాసినామా. E1 by, this is not equal, E1 by N1 is equal to 8, they given. So this is EMF per turn, induced EMF per turn. So don't take these two. EMF per turn is equal to 8. మనకి ఏం కావాలి, టర్న్ కావాలి. సో N1 is equal to EMF by 8. EMF ఎంత ఇచ్చున్నాడమ్మా, వాడు ఏమి ఇవ్వకపోతే సో ఇది తీసుకుంటాం 250 volts, ఎందుకంటే మనం E1 తీసుకుంటాం కాబట్టి. సపోజ్ E2 తీసుకుంటే E2 by N2 is equal to 3000 volts, sorry 8. సో E2 by 8 is equal to, సో N2, E2 అంటే అప్పుడు 3000 తీసుకుంటాం, E1 అంటే 250 తీసుకుంటాం, E2 అంటే 3000 తీసుకుంటాం, వాడు ఇవ్వనప్పుడు. Therefore N1 is equal to 250 by 8, N2 is equal to 3000 by 8. So number of turns N1 is equal to 32, N2 is equal to 375. So number of turns in the secondary is more. What type of transformer? Step up transformer. Number of turns ఎక్కువగా ఉంటే step up transformer. And then find the area, and area means we know the E1 is equal to 4.44 F N1 BMA, otherwise E2 is equal to 4.44 F N2 BMA. They given BM value 1.2 Weber per meter square. We have already find out N2 is equal to 375, F is equal to 50 Hz. Therefore E2 is nothing but 3000 is equal to 4.44 F 50 into 375 into 1.2 into A. So for that A is equal to A is equal to 0.03 meter square. A is equal to 0.03 meter square. Like that, how to determine important problem. Next class, I will discuss some more problems on EMF equation, and then we go for the another concept, transformer on no load or load. So very important conceptual concept, that is very interesting concept in transformer. లోడ్ లేకపోతే ఎలా ప్రవర్తిస్తుంది, లోడ్ ఉంటే ఎలా ప్రవర్తిస్తుంది, రైట్? ఎనీ క్వరీస్ ప్లీజ్ ఆస్క్ మీ. బాబు